Welcome to The Explainer. If you're diving into AI, you've got to know what's going on under the hood. So today, we're popping it open and looking at the real engine, the core statistical concepts that make the AI you work with every single day, well, work.
Right, so how does it think? Well, it's not some kind of magic. It's just math. And for you, as an IT student who's going to be building this stuff, getting these basics down is absolutely the key to unlocking its real power and making models that actually solve problems.
Okay, so here's our game plan. First, we'll talk about why stats are the bedrock of AI. Then, we're going to build what I call our Data Detectives Toolkit. We'll start by just describing the data, then visualizing it to find patterns, connecting the dots between clues, and finally, using all that to actually make predictions.
So, first things first. Why on earth should you, an IT student focused on AI, get bogged down in statistics? Simple. AI models don't learn from ideas, they learn from data. And statistics? Well, that's the language they speak to understand all of it. Think about it this way. You want to teach an AI to spot a spam email, or maybe predict the price of a house. You can't just tell it to. You have to translate that messy, real-world problem into clean numbers. Statistics is that translator. It gives you the rules to turn reality into a format an algorithm can actually learn from. All right, tool number one for our data detective. Before we can solve anything, we have to describe the scene. That means finding the most typical, the most central piece of evidence in our data, just to get our bearings.
This idea is called central tendency. It's really just a fancy way of saying we're looking for the average or typical value. It's the simplest way to take a huge pile of data and boil it down to one number. And we're going to zero in on the two heavy hitters, the mean and the median.
Okay, and this is where it gets really practical. The mean is what you probably think of as the average, but it's super sensitive to outliers. Imagine you're analyzing salaries, and you throw in the CEO's multi-million-dollar paycheck, bam! The mean salary gets pulled way up. The median, on the other hand, is just the middle number in the list. It couldn't care less about that giant CEO salary. It gives you the true middle ground.
So why does this matter? Because before an AI can spot something weird, like a fraudulent credit card transaction or a sensor that's about to fail, it has to have a rock-solid idea of what's normal. Central tendency is what gives your model that baseline for reality.
Okay, so now we can describe our data with a few numbers. But to really understand it, we need to see it. Visualizing the data can show you patterns you would totally miss if you were just staring at a spreadsheet.
You know, they say a picture is worth 1,000 words. Well, in our world, a good chart is worth 1,000 data points, easy. You can see trends, outliers, and the whole shape of your data in a single glance. It's just how our brains are wired.
I mean, take a look at this bar chart. It shows student meal preferences. Instead of a boring table of numbers, you can see instantly that Italian and Thai are tied for the most popular. It's immediate, it's clear, and it turns raw data into actual insight.
Now, a bar chart is awesome for categories, like food. But for numerical data, you want a histogram. It groups numbers into bins or ranges so you can see the distribution. Think about visualizing the range of test scores in a class, or the ages of all the users on a new app. That's what a histogram is for.
So, we've described our data, we've visualized it. The next move for our data detective is to start looking for connections. Are any of our clues related to each other?
And that brings us to correlation. You've probably heard the term, but in simple terms, it just tells us if two things tend to move together. When one thing changes, does the other one change in a way we can predict? This is really the first step toward building a model that can see the future.
Yeah, this is absolutely fundamental. A positive correlation is like the more hours you study, the higher your exam score tends to be. A negative one? Maybe the more time you spend gaming, the lower your exam score. Understanding this relationship is a huge part of exploring any data set.
And this is a huge deal for AI. Think about recommendation engines. They work because your past viewing habits are correlated with what you might want to watch next. The AI finds those connections and makes a prediction. But, and this is a big but, always remember, correlation is not causation.
And now for the final piece of the puzzle. We're going to use those connections we found to actually predict the future. This is where we make the jump from just analyzing data to foundational machine learning. This one's called linear regression. Sounds complicated, but the idea is actually pretty simple. Imagine you plot all your data points on a graph, just a scatter of dots. Linear regression is just a method for drawing the one single best straight line that slices right through that data, getting as close to all the points as possible. It's the line that best captures the trend.
Now, yeah, there's a specific formula to find this best fit line, but don't get hung up on the math right now. The big idea is that the algorithm systematically calculates a slope and an intercept for a line that has the smallest possible error. That just means the average distance from the line to all of your data points is as small as it can possibly be. It's a mathematical way of finding the perfect trend line.
This simple line is actually a basic, but super powerful form of what we call supervised machine learning. We call it supervised because you're training the model on data where you already know the right answers. And this is the fundamental building block for models that predict everything from stock prices to future sales numbers.
So, let's wrap up with our Data Detectives toolkit. We learned to describe the scene using mean and median. We learned to visualize the evidence with charts to spot patterns. We connect the clues using correlation. And finally, we predict what happens next using linear regression. Each tool builds on the last, and together, they take you from a mess of raw data to actual actionable insight.
Look, mastering these ideas isn't just about passing a math test. It's about learning the fundamental logic for how machines make sense of our world. These are the building blocks. The real question is, what are you going to build with them? Thanks for joining this explainer.